All right, let's look at two more examples of linear regression and this idea of interpolation. The first one is going to be about push-ups in video games. So the relationship between hours of video games played per day and the number of push-ups a person can do is given by the following linear regression model, where x is the hour of video games played. So we have f of x or y is equal to negative 1.302x plus 38.449. So our first question here is thinking about the scenario and that x represents the number of hours of video games played in a day, what values of x seem reasonable for making predictions or for this process of interpolation? So since x represents the number of hours in a day, I think we could probably safely narrow this down to 0 to 24. You certainly can't play less than 0 hours. You can't play more than 24. So that's one practical consideration. Another one is going to be that the number of push-ups, so our output, has to be a positive number. So you can't get a negative number of push-ups out. That's not going to work, and just in terms of practicality. So what I want to do is take a look at this graph and make sure that if I'm using 0 to 24, that it doesn't result in a negative y value. Okay, so I used Desmos to go ahead and graph this. So let me zoom out so we can take a look at this graph. So I have the hours of video games played. So we go 0 to 24. And then we have number of push-ups on our y-axis. And as you can see, this whole line stays positive. So we stay above the x-axis. It actually looks like we go from about 38 down to maybe about 7. Okay, so those are all positive numbers, so I don't have any concerns looking at this graph. So I would say in terms of interpolation, you zoom in here, I would say that we could choose x's between 0 and 24. Seem fairly realistic. Maybe 24 is a bit of a stretch, but somewhere in that neighborhood seems pretty good. And then we're going to predict the number of push-ups a person who plays 6 hours of video games per day can do. So we'll take our equation here. So I have y is equal to negative 1.302. And we're going to multiply that by x equals 6. So I'll substitute a 6 in. And then we're going to add 38.449. When I plug that into a calculator, I get roughly 30.6 push-ups. In this case, or in this context, it would be perfectly fine to round that to 31 push-ups, since it's kind of a little bit tricky to do anything other than a whole number of push-ups. All right, so we have one more here. This one is on the cost of airfare. So we have a relationship between the distance traveled and the cost of the ticket. So we do have a linear regression model with y equals 0.117x plus 83.267. So you have a couple questions here. You're going to figure out what values seem reasonable. Make sure that these two that I'm asking for a predicted value fit in here and seem reasonable. And then you're going to plot these points on the scatter plot. So what I'd like for you to do is go ahead and pause the video and give these a try. All right, so hopefully you gave those a try. We're going to start with looking at what values seem reasonable for making our predictions. So our interpolation. If I start here on the low end, since we have data points, it's kind of a nice way to do this. It looks like kind of my low end is maybe around 200. So maybe 150, 200, somewhere in there. It's kind of going to be our low end. And then on our high end, it looks like, I don't know, maybe about 1,500 or so. Maybe 1,600 might be fair game. I would think a little bit beyond that might be okay, but not too much. All right, so I have the values for interpolation. So it seems like anything between 200 and 1,500 is fair game. So we're asked to find the predicted cost if the flight is 370 miles and 1,350 miles. So both of those fall in here. So we're going to go ahead and work those out. So we get y is equal to 0.117 times 370 plus the 83.267. And I got roughly about $126.56 for that flight. okay, of 370 miles. And this one that is 1,350 miles, that's quite a bit further, so I would expect that to cost a little more. Let's go ahead and find that. So I have y is equal to 0.117 times the 1350 plus 83.267. So let's get this one in here, 0.117 times 1350 plus 83.267 gets me about $241.22. Okay, so there are my two predictions. And then in terms of illustrating these, so if I'm looking at 1350, that's probably right about here for an x value. And so there is my y value, and that sure looks like it is really close to 250. So 241.22 seems reasonable. And then this one that's 370 miles is probably about here. Okay, and so we got a value of $126.56, which is exactly kind of where that looks like it falls. Okay, so anytime you're making a predicted value, it's going to fall exactly on the line. Your data points will be all over the place. Some might be on the line, some won't be on the line. But anytime you do a predicted value, it's always going to be sitting right on the line. All right, come back in the next video. We'll talk a little bit more about extrapolation.